Next, capacitor start motor. Capacitor start motor. Okay, so single phase induction motors are classified into two. One is split phase motor. We discussed the working of a split phase motor in the last class. Now we are going to discuss about the second category induction motors, that is capacitor start motor. So these types of motors are used in grinders, washing machines, etc. Okay, so in this case also there are two windings in the stator. One is main winding or running winding and other is starting winding. A capacitor is connected in series with the starting winding. A capacitor is connected in series with the starting winding and a centrifugal switch is connected in series with the starting winding. So starting winding consists of centrifugal switch, starting winding and a capacitor. Both are connected, all the three are connected in series, and that series combination is connected in parallel with the main winding. Okay, centrifugal switch, starting winding and capacitor are connected in series. All the three are connected in series. That whole combination is connected in parallel with the main winding. That whole combination is connected in parallel with the main winding. This combination is connected across a single phase supply. Okay, here both windings have same characteristics. Both of them have low resistance and high reactance. The windings are individually a inductive circuit. But here a capacitor is connected in series with the starting winding, thus it acts as a resistive circuit. When a capacitor is in series with an inductor, definitely it shows the characteristics of a resistive circuit. When a capacitor is connected in series with the winding, definitely it shows the characteristics of a resistive circuit. Okay. Now, when we give single phase supply to this parallel combination, the currents are splitting. One part is flowing through the starting winding IS and other current is flowing through the main winding IM. I is the phasor sum of IS and IM. In the case of split phase induction motor, the angle difference between IS and IM is alpha, which is about 25 to 30 degree. Here, the angle difference between IS and IM is more than that of split phase induction motor. Here, the angle difference between IS and IM is 80 degree, almost 80 degree. And therefore, in this case also, with the help of a capacitor, we can split the phase. But that phase difference between IS and IM is very large, which is about 80 degree. And which have thus two phases are flowing through its stator, which can create a rotating magnetic field. In the earlier case, in the case of a split phase induction motor, that angle difference is only about 25 to 30 degree, which also creates a rotating magnetic field. Because of the low angle difference between IS and IM, there is a low starting torque in the case of a split phase induction motor. Here starting torque is more. Torque equation is T is equal to K into IS into IM into sin alpha. In the case of split phase induction motor, alpha is very low, which is about 25 to 30 degree. In this case, alpha is about 80 degree. Therefore, torque is equal to K is a constant into IM into IS into sin alpha. Therefore, the value of alpha is greater than that of a split phase motors. So, starting torque of a capacitor motor is greater than that of a starting torque of a capacitor motor is greater than that of a split phase motor. Starting torque of a capacitor motor is greater than that of a split phase motor. So two currents are flowing, two phases are produced, which can create a rotating magnetic field. Angle difference between IS and IM is alpha is equal to 80 degree here. So starting torque is much higher than that of the split phase induction motor. Okay. After that, the working of capacitor motor is exactly same as that of a split phase induction motor. That means after developing the rotating magnetic field in the stator, which pass through the air gap and cuts the stationary stage squirrel cage rotor conductors, and an EMF is induced in the rotor, according to Faraday's first law of electromagnetic induction. An EMF is induced in the rotor according to Faraday's first law of electromagnetic induction. As the rotor is a closed circuit, a current circulates through it known as eddy current. This eddy current opposes the rotating magnetic field in the stator. And the opposition exerts on the rotor itself. And the rotor starts to rotate. And the rotor starts to rotate in the same direction of magnetic field. Rotor starts to rotate in the same direction of magnetic field, but not at the same speed. The speed of the capacitor motor is less than that of the synchronous motor. Speed of a capacitor motor is less than that of a speed of the capacitor motor is less than that of a synchronous motor, whose speed is less than synchronous speed. So it is an asynchronous motor. Starting torque T is equal to K into Is into Im into sin alpha. In the earlier case, in the case of a split phase induction motor, the angle difference is very low because starting winding acts as a resistive circuit, running winding acts as an inductive circuit, and starting winding is not much resistive as in the case of a capacitor motor, so angle difference will be very low. Starting winding is not so much resistive as in the case of a capacitor motor, so angle difference between Is and Im is very low. In this case, starting winding has much resistive characteristics than that of a split phase motor, therefore angle difference between Is and Im is comparatively larger. Okay, that's the capacitor start induction motor. When the motor attains 80% of its rated speed, and the capacitor start induction motor attains 80% of its rated speed, its starting winding is cut off by the centrifugal switch. Because when the machine attains 80% of its rated speed, centrifugal switch is cut by due to the axial movement of the shaft of the machine. When the machine rotates, or when the machine attains 80% of its rated speed, there is an axial movement of shaft takes place. Due to this axial movement of shaft, centrifugal switch becomes cut off, and starting winding circuit will be electrically cut off. Starting winding circuit will be electrically cut off, and there is no current flow through the starting winding. Okay, there is no current flow through the starting winding. Thus, the starting winding circuit is electrically cut off. The starting winding circuit is electrically cut off from the motor. Thus, under normal running condition, each stator consists of only one winding. Under normal running condition, each stator consists of only one winding known as main winding. Under normal running condition, each stator consists of only one winding known as a main winding. I think this topic is clear. Okay. The value of capacitor is so chosen that it leads Im by about 80 degree. That is, alpha is equal to 80 degree, which is considerably greater than 25 degree as in the case of a split phase induction motor, as this discussed in all these topics I discussed just now. Okay.